Yes. So week 5 mainly cover about the first order filters. Week 6 the professor cover the second order filter. In the second order filter they basically discuss the low pass, band pass filter and high pass filters. So if we are going to design a circuit, like for example this is my operation amplifier. Okay, one resistor, one more resistor, one capacitor is here, one capacitor is here, that is also grounded. VI. Okay, so this type of second order filters they design in the, like, if either replace with the resistor with the capacitor or capacitor with the resistors. Okay, this is the one circuit. If I go with the second circuit, so the op amp, capacitor, capacitor, resistor, resistor, V naught, ground. So this become positive, this negative, this become positive, this negative. Mm, this is VI. Okay, so these two particularly filters the professor discussed in the week 6. Now, first of all, the for the week 6, professor design a one transfer function, that is a generalized transfer function, because it is a second order. Okay, it is a second order. The second order equation is like there are two poles are available. So if I say the V out upon Vi is equal to A naught DC gain upon 1 plus S upon P1 and 1 over 1 plus S upon P2. Okay, second order that means two poles are available. The location of poles are, we are considering that one pole, particularly pole is at P1 and one particularly pole as P2. Okay, so that's why two poles they have discussed. Okay, now if I multiply this particularly system, if I multiply or basically find the equation, so it become a 1 plus S square upon P1 P2 plus S 1 upon P1 plus 1 upon P2. Okay, now we compare this equation with our standard equation. The standard second order transfer function equation is A naught or 1 upon 1 plus S square upon omega P square plus S upon omega P cube. Okay, S upon omega P QP. This is the generalized equation of second order system. Now there are two terms we define. One is the omega P and second is the QP. As we already discussed, QP is nothing but a quality factor. In the previous class, we discussed about QP, and omega P is the pole frequency. Because of this, frequency will be generated due to the poles, so that's why it is called the pole frequencies. Okay, so yeah, any doubt?
No, sir. No, sir.
Now, if what we are getting, like this is my generalized equation, from there we are getting the omega p qp. Okay, now if I solve this particularly equation or calculate the transfer function for this given circuit, okay, transfer function for the given circuit, so how we calculate the transfer functions of that one? Like we are saying this is the voltage V1, this is the voltage V2. So we basically calculate the transfer function for this particularly system, and that transfer function, if we relate this transfer function with our standard equation, so we will calculate the value of omega p and q. Okay. Now, if this generalized equation, if we calculate what is the poles location S, okay, poles location. So how we get the poles location? This is a second order quadratic equation. So if we solve this second order quadratic equation for the S, so the formula is minus b plus minus b square minus 4ac divided by 2a. So what is the b? The value of b is this one. Okay. The value of a is this one, and the value of c is this one. Either you consider this one as a A, or either you consider this one as a C. Okay. So if I compare this is as a S square plus B S plus C. Okay. So the S term is the B, multiplication of S term is the B, multiplication of S square term is the A, and constant term is the C. So if I calculate, put the value here, so it is a 1 upon omega p qp root of 1 by omega p qp square minus 4 upon omega p square divided by 2. Okay, if I divide this one, so the value of S is minus 1 upon 2 omega p qp plus minus, when I two take this side inside this one, so it becomes a 1 upon omega p qp, 2 omega p qp का square minus 1 upon omega p square. Okay,
Yes, sir.
now with respect to this one, can I solve out? Can I take a omega p as a common? Mm, So what we can do with this one is, okay, this is the 2 upon omega p. 2 upon omega p square. Okay, because a is 1 upon omega p square. So it is a 2a. Okay, so it's is equal to s equal to minus omega p upon 2 qp plus minus root of mm, omega p upon 2 qp square minus omega p square. Okay, and omega p I am taking common. So s is equal to minus omega p upon 2 qp plus minus omega p root of 1 upon 2 qp square minus 1. Okay, now this term 1 upon 2 qp square minus 1, this will be decide that my system will be response is what? My system response is what? Okay, so if I say that the possible value is what? 1 upon 2 qp square minus 1 should be greater than 0. Okay, so I just mentioned that it is a minus of mm, sorry, 1 upon 4 qp square minus 1 greater than 0, 1 upon 4 qp square minus 1 is equal to 0, 1 upon 4 qp square minus 1 less than 0. Okay, so three possibilities are available. 1 upon 4 qp square is greater than, equal to, and less than. Now if it is equal to 0, so we have a s is equal to minus omega p upon 2 qp. So two poles are available and the position of these two poles are same, minus omega p upon 2 qp. Okay, why two poles? Because the term is the equation is the second order quadratic equation. So if second order quadratic equation is available, so that means two poles are available. Now if this particular term will be 0, this term is 0, so that means this plus minus term will be 0. So only s is equal to minus omega p upon 2 qp. So that means both poles will be available at a same location. Okay, if, yeah, any doubt?
No, sir. No, sir.
Okay, if we say that 1 upon 4 qp square minus 1 is greater than 0, that means the poles is the real pole. The poles are the real poles. Okay, so if it is a real pole, so what is the value of omega p? Sorry, what is the value of qp?
Less than 2. 1 QP less than 1 upon 2.
For 1 by 4 qp square is greater than 1. That means 4 qp square is less than 1. qp square less than 1 by 4 and qp less than 1 by 2. Okay, so this is the one particularly quality factor for which one the poles are real. Now if the poles are real, so I can mention that is it is as a mm, s is equal to minus omega p upon 2 qp plus minus omega p into, I say that this particularly is the delta, any value, okay, any particularly by value, so it is a delta. So on the basis of this one we are getting a two poles. One pole is what? Minus omega p upon 2 qp plus omega p time delta, and one is minus omega p upon 2 qp minus omega p time delta. Okay, now
Yes, sir.
if it is equal to 0, we could know that there are two poles are available. And what is the value of qp? So 1 upon 4 qp square is equal to 1. 4 qp square is also 1. qp is equal to 1 by 4. That means qp is equal to 1 by 2. Okay, and when it is less than 0, so there are two complex poles. Okay, and complex poles. Now what is the value of this particularly is qp is greater than 1 by 2. Okay, and what is the value of complex pole is s1 and s2 is equal to minus omega p upon 2 qp plus j times of omega p. I just say that that is also a delta, any value. Okay, so there are two poles are available. One is the minus omega p upon 2 qp plus j time of omega p into delta, and minus omega p upon 2 qp minus j times of omega p into delta. That is s1 and that is s2.
सर
Yeah,
सर ये पोल वगैरह हम मतलब वैसे क्यों निकाल रहे हैं मतलब फील नहीं आ रहा मतलब रियल लाइफ में कहाँ यूज है इनका ये पोल
exactly. Okay, 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 okay. Basically, if we find the poles, okay, poles. Why we find the poles is that we have to identify the stability of system. Okay, like for example, I say that you discuss about the root locus. You study about the root locus. Have you studied root locus? Yes or no?
हाँ सर, याद तो नहीं है, पढ़ा तो था शायद।
Root locus. Okay. I think in control में आपके in control it will be covered in more details.
यस
Okay,
सर।
root locus part. So basically, what the root locus says that if we have poles, okay, so like for example, two poles are available. Okay, so these poles will be terminate on the zeros. These poles will be terminate on the zeros. Now, where the zeros are available, zeros are available on the infinite. Okay, so these poles are terminated on the zeros, and that zeros will be available on the infinite results. Okay, so if we say with respect to these two is that my root locus will exist in left hand side of j omega axis. This is the j omega axis. This is the sigma axis, sigma real component, real axis. Okay, so if root locus will exist on the left hand side of j omega axis, we can say my system is stable. Okay, now one position is that my root locus, my both particularly poles will be available on the real point. Second is what, my particularly root locus will be available in the this position or in this position. Why these two pocket positions? Because it is a complex. It is a complex. This one. Okay. Now, if I draw the basically if I draw the locus area of this pole, so the locus area will be like that. If I draw the locus area will be like that. Okay. One situation where that particularly part is the real particularly poles are available, both poles are real. Okay, omega p upon 2 qp, this one is where basically it will be increase with the omega p upon 2 qp, and one way it will be decrease with omega p minus omega p delta. Okay, so one particular position is that one, the it will be available in this one and this one. Okay, that particularly is called the omega p upon 2 qp with minus sign. That particularly is called the minus of omega p upon 2 qp minus omega p time delta. This is I call the omega minus omega p upon 2 qp plus omega p time delta. Okay, and this one is what, omega p upon 2 qp plus j omega p delta, and this particularly is what, minus of omega p upon 2 qp minus j omega p delta. Any doubt in this representation?
नो सर।
Now, if we say that when it will be cut the real axis, this point, when it will be cut the real axis. So, what is the value of this one? It is QP less than 1 upon root 2. Sorry, 1 upon 2. Now, at this point, it will be QP greater than 1 by 2. Okay. Now, if we further increase the value of QP, if we further increase the value of QP, if we increase the value of QP and if we increase more increase, then QP value is greater than 1 by 2. Okay. So what it will do? The root locus will be moved toward the j omega axis, towards the j omega axis, and after a certain value of QP, it will be cut down the j omega axis. It will be cut down the j omega axis. And if it will be cut down the j omega axis, that means the now the root locus will be lies in the right hand side of the j omega axis, or we can say my system is unstable. Okay. So the purpose of calculating these poles is what? If these particularly second order system, I just already told in the previous class that first order system is stable, second order system is stable, and third order system is unstable. Have you remember that thing? In the previous class we discussed first order and second order system is stable and third order is unstable.
Yes, sir.
That's why we are not going on the higher order. We are only discussing the first order, second order, and probably sometimes the third order. Okay. But the thing is that second order system may also be unstable. That particularly is dependent on value of QP. First, so on the basis of why we calculating this pose is that if we are talking the first order, it is completely stable. Okay. If we are talking about the second order, it is stable. Okay. But for certain value of QP, if QP is much greater than 1 by 2, it's becoming unstable. Okay. Now, if we are talking the third order system, okay, it is stable only for small value of QP. Okay. What is the value of QP for which it is stable? We will discuss in the third when we are discussing the third order. But it will be stable only for a very small value of the QP. Okay, and if I change the value of QP, like for example, if you see that 1 by 2, if I take the 1 by 2, it is a completely unstable. Okay, so to identify the stability of first order, second order, and third order, we define the poles. We define the poles. Okay, after on the basis of that poles, we are basically create a locus of that one. Okay, how the poles will be vary, and according to this one, how my locus will be going on. Okay, and on the basis of that one, I can conclude that when it is a QP is less than 1 by 2, my poles are here. So that means it is a completely stable. Why? Because it is a much distance from the j omega axis. So there is no possibility that it will be cut down the j omega axis. So always poles, always stable. When we increase the QP up to the 1 by 2, it is just go near to the j omega axis. Why? Because this one, it is just near go to the j omega axis. The distance from the j omega axis is less as compared to previous case. Okay, so the stability is less. stability is less. Why? Because if the distance is less, stability is less. Now if we further increase the value of qp at a certain particularly value, it will be cross the j omega axis, it will be go into the right hand side, and we can say the stability is 0. That means system is unstable. So that's why to define the stability, we basically calculate the poles. Now clear?
Yes, sir. Clear.
So now if we calculate the response, so basically h of j omega, so it becomes a, if I say 1 over 1 minus omega square upon omega p square plus 2, sorry, plus j omega upon omega p cube. If I find the magnitude of this one, so it is a 1 over the real component square plus imaginary component square and root of this one. So 1 minus omega square upon omega p square whole square plus omega upon omega p cube whole square and root of this one. Okay. If I solve this one, so 1 upon 1 plus omega 4 upon omega p 4 minus 2 omega square upon omega p square plus omega square upon 2p square omega p square and root of this one. Now can I take a omega p square as a so 1 plus omega square upon omega p square. I take a common from these two, that is a 1 upon 2p square minus 2 plus omega 4 upon omega p 4. Okay. Now if we say the response, so omega upon omega p less than 1 and omega upon omega p greater than 1. Okay. So if omega upon omega p is less than 1, so I can say omega upon omega p raised to power 4 is also less than omega upon omega p square. Why? Because if I say that omega upon omega p is 0.1, so e raised to power 4 is 0.0001, that is less than 0.1 square is 0.01. Okay, so if omega upon omega p is less than 0.1, so that means that when we increase the power, the value will be lesser. Okay, so if the value will be lesser, so can I neglect this term? Okay, so basically h of j omega mod square is equal to 1 over 1 plus omega square upon omega p square 1 over qp square minus 2. Okay, now again qp square minus 2 will be defined. Okay, qp square minus 2 will be defined the response graph. So if I say 1 over qp square minus 2 will be less than 0, 1 over qp square minus 2 will be equal to 0, and 1 over qp square minus 2 will be greater than 0. Sorry, greater than 0, less than 0. Okay, so if I say if it is a greater than 0, so the value of qp is what? Less than 1 upon root 2. Okay, if the value is less than upon 1 upon root 2, so this value is greater than 0, so it becomes a 1 over root of 1 plus Oh, sorry, it is not a square. It is not a square. If I take a square, so I have to remove this square. 1 over 1 plus omega square upon omega p square minus delta. Okay, I just mentioned as a delta. Greater than 0, that means delta. Less than 0, minus delta. Okay, so if I take this one as a delta, okay, so we will take leave it here. Now if qp 1 upon qp square minus 2 is 0, so it becomes a qp is 1 upon root 2. Okay, and h of j omega mod square is nothing but 1 over 1, because this completed term is 0. Okay, and when it is less than 0, so qp is greater than 1 upon root 2, and magnitude h of j omega mod square is equal to 1 minus omega square upon omega p square into delta. It is less than 0, that means minus delta. Okay.
Yes, sir.
Yeah. Okay. So when I increase the omega, suppose for example, when I take the omega is equal to omega. Okay, now take the omega is equal to omega p. The graph is 1 over 1 plus delta. It is 1 over 1, and this is 1 over 1 minus delta. Now, if I increase the omega is greater than omega p, or I increase the omega. So when I increase the omega, 1 upon 1 plus this factor, omega upon omega p square. So when I increase the omega, so omega upon omega p is greater than 1. Okay, so I just mentioned it as a beta, that value is greater than 1. Okay, so it is a beta delta, and the overall value, this particular term will be increased, that means overall term will be increased. If overall term will be increased, that means this particularly will be decreases. Okay, so for understanding purpose, when I increase the omega, so omega upon omega p is greater than 1, so my h of j omega mod square will be start reducing. Okay, here it will be constant as a 1, no effect of greater than and less than. Okay, and in this case h j omega mod square. Now if you increase this particular omega, so this term will be increased. Okay, beta. If this term is increased, that means this term is increased, and this term is decreasing. Okay, this term is decreasing, so I can say that h of j omega will be increased. Clear? Any doubt?
No, sir, clear.
Okay, now if I take the response of low pass filter, so what is the practical response of low pass filter is that it will be a 1, and then after that it will be start reducing. Okay, it will be 1 and it will be start reducing. Now what is the effect of qp here is that if qp is greater than 1 upon root 2, qp is less than 1 upon root 2. So when QP is less than 1 upon root 2, okay, as we increase the frequency, the h of j omega will be reducing. So when I increase the frequency, the h of j omega will be reducing. Okay, why? Because it is response for QP less than 1 upon root 2. Clear? And similarly, if we are talking about the greater than QP greater than 1 upon root 2, so as we increase the omega, it will be increasing. So when QP is greater than 1 upon root 2, as we increase the omega, it will be increasing. Okay. Now, if it is increasing or it will be decreasing, so in your mind it is a doubt that then it is not a low pass filter. No, exactly it is a low pass filter. So what will be the happen? It will be initially start increasing. Then when it goes to the cutoff frequency, it will be response will be like this. Okay. If it is a decreasing, so the response will be like that. So after cutoff frequency, the response is constant. But before the cutoff frequency, one response will be increasing and one response will be decreasing. One response is remain constant at 1. There is no effect of the any value changes, any frequency changes. Okay, and that particularly constant is what? When QP is equal to 1 upon 2. Okay, any doubt? And that QP is equal to 1 upon root 2 is called the special case. The special case.
Okay, sir.
Okay,
Clear. Yes, sir.
now the second thing we did is we remaining in the backside is that if omega upon omega p is greater than 1. Okay, now in this case, the omega upon omega p raised to power 4 is much greater than omega upon omega p square. Okay, so this term will be neglected, this term is neglected. So what is the h of j omega? Square is 1 upon square is omega 4 upon omega p4, that is equal to omega p4 upon omega 4. And if I take the magnitude only, so take a square root, so it become a square omega p square upon omega square. But that condition will be arise after cutoff frequency. After cutoff frequency. So as I already told you with the graph that it will be start increasing on the basis of QP value, it will be start increasing on the basis of QP value, it will be start decreasing. But after we receive the cutoff frequency, there is no effect of QP. There is no effect of QP. So you can see from this particular equation also. Okay, so when we increase the frequency of basically omega is greater than omega p cutoff frequency, after that there is no effect of QP. Only the effect is omega p and omega is there. Okay, clear?
Yes, sir.
Okay, so the all the effect like it is a increasing behavior or it is a decreasing behavior, or all will be before the omega is equal to omega. And if I say that this is the omega is equal to omega p, or omega upon omega p is equal to 1, this is called the cutoff frequency where the response will be the 1 by 2, 1 upon root 2. for all particularly graph. Okay, after that every response will be similar. Let that will be discussed in the week 6. After that, I think the professor discuss similar response for the band pass filter also. Okay, so for the band pass filter, what is the uh, system function is h bp of s is equal to, I think, s upon omega p qp upon 1 plus s square upon omega p square plus s upon omega p qp. Okay, now again you calculate the put s equal to j omega, that becomes h band pass, sorry, h bp of s is equal to j omega upon omega p qp upon 1 plus 1 minus omega square upon omega p square plus j omega upon omega p qp. Now take the magnitude. So when we take the magnitude of numerator, so it is omega upon omega p qp upon root of 1 minus omega square upon omega p square, the whole square plus omega upon omega p qp whole square. Okay, that is the HPP of j omega magnitude. HPP of j omega magnitude. Okay, so from that one you can find out the cutoff frequency. How we calculate the cutoff frequency? Basically putting the value of 1 upon root 2. Okay, we are getting the value of 1 upon root. Okay, so if I take a square of that one, so it becomes a omega square upon omega p qp square upon, sorry, cancel out, cancel out. So 1 minus omega square upon omega p square whole square plus omega upon omega p qp square is equal to 1 by 2. Okay, so mm, I think they basically define as a omega upon omega p qp as x. No, sorry. They define a omega square upon omega p square is as a x. This term as a x. Okay. So the equation is x upon qp square upon 1 minus x square plus x upon qp square. That is equal to 1 by 2. From that one, they calculate the value of x. Okay. Now x is already omega square upon omega p square. So you can calculate the two frequencies at which it will be the 1 by 2. Okay. Now why we are getting a two frequencies? Because it is a band pass filter. The response of band pass filter is what? It is uh, somehow this one. This is the maximum magnitude Here we are saying that it is the maximum magnitude to be 1 upon root 2 times. With respect to this one, we are getting the two frequency omega C1 and omega. Okay, so you can solve that. Uh, okay, along with that one, they are calculating the value of x1 and hmm, I think in this particular till that the professor will discuss about the responses. Now, how we implement, how we basically use this particularly equations or how we calculate the response for a circuit, because till now the professor is not discussing any circuit, second order system. Okay, so how we basically design a circuit and after that how we implement the response of that one. Okay, so that is the next part we will cover in the next class. Okay, so I think two classes are more required for week 6 and week 7. Either we can do with the tomorrow and on Tuesday.
Yes, sir.
Okay, and for week 8 I already inform you that you have to go with the iFixit uh, airport tear down video. Okay, when you search on a Google iFixit airport tear down, so from that one you just find out, you just read out that document, and then from that document you can find your answers.
Hello, sir.
Yeah, yeah.
Sir, which type of question will be asked in quiz 2 from week 8? Because there is mainly theoretical question.
Yeah, basically theoretical questions. So, like for some system is given, the power rating or battery rating will be given, asking in the question, ask type question will be asking. Okay, second, if they ask some particularly subsystem, they will ask with you that what is the how Bluetooth subsystem. Okay, that we discuss in the class, and they will ask that what is the basically internal part of the power management unit. Okay, I think that will be also cover. So this type of question, theoretical question will be asking, and if we are going with the numerical, so they ask the power rating or basically this type question they ask. Okay, theoretical, two or three questions are theoretical question, like they are asking you about the design, draw a subsystem, Bluetooth subsystem, Bluetooth handset system. Okay, and mention all particularly required subsystem in that one. Okay, this type question will be asking, either they ask particularly define any subsystem is given, so they ask that what particular subsystem is this one, what is inside that particular subsystem, like for example power management and battery subsystem, they discuss something in the week 8 videos, so they ask that one also. Okay, and basically if we are going to the numerical part, so some power rating, voltage rating question they ask in the numerical part. Okay, so two or three questions is only in that particularly we get. Yes, 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 and Alkesh ask your
Sir,